Okay, in this video, we're going to be doing Calc AB problem set number 97. So the problems and a playlist are in the description below, and let's do it. Number 1, the line tangent to f of x equals x minus 3 over x plus 8 at x equals 4 is used to approximate f of 4.1. Does this result in an over or underestimate of the true value? And we have to justify it. All right, so over underestimate with tangent lines, we need to know concavity, so we're going to have to get the second derivative. So we're going to quotient rule this thing. All right, bottom, derivative of the top is 1 minus top, derivative of the bottom is 1, all over the bottom squared. It's useful to simplify this, so we get x minus x, and then 8 plus 3. So we end up with 11 over x plus 8 squared. I actually think because we need the second derivative, it's more convenient to write it as 11 x plus 8 to the negative second, so that we can just like power rule, chain rule it. So f double prime, I'm going to bring down the negative 2. That gives me negative 22 x plus 8 to the negative third, and then times 1 by the chain rule, but we don't write that. All right, we're going to do a sign chart for this and then answer the question. So sign chart, I guess I'm going to rewrite this. Okay, good deal. Sign chart, we put negative 8 on the sign chart. F double prime is the thing that we're testing. If I plug in negative a billion, I get negative 22 over a negative cubed, which is negative, so negative over negative, positives. If I plug in a billion, I get negative 22 over a positive cubed, which is positive, so negative over positive, definitely negatives. Okay, so now what interval do I need to be on? The tangent is at x, I'm approximating 4.1, so because of that, I'm on this interval where x is greater than negative 8. So I'm going to say, yeah, x is greater than negative 8, so f double prime is negative. So f double prime is less than 0 on the interval. You don't have to watch this. On the interval from 4 to 4.1, therefore f of x is concave down on that interval. And if f of x is concave down, the tangent line will give an overestimate of the true value because the tangent line is above the curve. That's how I would answer that question. Next up, what are we doing? Okay, the function g of x is differentiable, increasing, and g double prime is greater than 0. So it's increasing and concave up. Use the table of values to answer the questions. Approximate the integral from 0 to 16 with a left sum. And then is your approximation over or underestimate and why? Okay, so left-hand sum. So 0 to 16, g of x dx is approximately equal to, that's required. We're doing a left sum, so it's going to be 6. The left, 0 to 6 is 6, and then the left would be 1. And then 6 to 13 is 7, and the left would be 5. And then 13 to 16 is 3, and the left would be 12. Then we add all those up, we get 77. AP exam, you can actually leave it. You don't have to simplify it to 77. I think it's a good idea, but you don't have to. Now, over or underestimate, we are told that the function itself is increasing. So let's just draw an increasing function. I chose to draw increasing concave up because that's what we're told, but increasing concave down, you would get the same result here. Draw a couple of rectangles. You can see your left rectangles are always under the curve, so this is an underestimate. So I will say, since g of x is increasing, a left sum gives an underestimate, and that's it. So the reason why it's an underestimate is because g of x is increasing. That's our reasoning. All right, let's do B. Approximate 0 to 16 g of x dx with a trapezoidal sum. All right, so our integral is approximately. Every trapezoid, it's 1/2. And then the height, which is from 0 to 6, so 6. And then the sum of the bases, so 1 plus 5. That's our first trapezoid. Plus 1/2, because it's a trapezoid, from 6 to 13 is 7. The sum of the bases is 5 plus 12, so 17. And then 1/2, because it's a trapezoid. 13 to 16 is 3. And then the sum of the bases is 12 plus 20 is 32. You calculate this, and you get 125.5. So now we need to decide, is this an over or underestimate? Well, generally speaking, calculus problem, you can't really make this generalization, but I'm going to do it anyway. You aren't usually given extraneous information. There's a piece of information we didn't use yet, and it's the fact that g double prime is greater than 0, right? G double prime greater than 0 means that the curve is concave up. If I just sketch a concave up thing and then draw a trapezoid, you can see the trapezoid is definitely going to overestimate. So I now know the answer is overestimate. I need to give a reason. So I'm going to say, since g double prime is greater than 0, g of x is concave up. And because of that, a trapezoidal sum will give an overestimate. So that would be my reasoning on that. I think that's a good answer. All right, let's take a look at the next part, part C. Given that g prime of 13 is 5 and that h of x is g of x times e to the 2x, we need to find h prime of 13. So I'm going to start off by finding h prime of x, right? H prime of x is going to require the product rule because it's a product and a little bit of chain rule. So first, the derivative of the second is 2e to the 2x plus second, which is e to the 2x. Derivative of the first is just g prime of x. So now we need to find h prime of 13. So I'm going to take every x and replace it with 13. 2 times 13 is 26. You're going to see a bunch of 26s show up. So we get h prime of 13 is g of 13 times 2 e to the 26 plus e to the 26 times g prime of 13. Now, g of 13 we can find from the table. G of 13 is 12. And g prime of 13 is given. It's 5. So we're going to have 12 times 2 e to the 26th plus 5 times e to the 26th. 2 times 12 is 24, plus 5 is 29. We get 29e to the 26th. All right, let's take a look at the last question here. Evaluate. The limit as h approaches 0. As soon as I see that without even reading on, I'm thinking this is the limit definition of the derivative. Limit as h approaches 0. It should be f of x plus h minus f of x divided by h. And we see natural log of sine of x plus h minus natural log of sine of x all over h, which means that f of x, the thing we're finding the derivative of, is the natural log of sine of x. So when it's written kind of conventionally, f of x is in like the top right corner of the fraction. It's in the numerator and it's like on the right. So the derivative of natural log of something is 1 over that thing times the derivative of that thing. So it's going to be 1 over sine times the derivative of sine, which is cosine. And then cosine over sine is cotangent. So a little bit of trig identities at the end there, but not bad trig identities, or just definitions of trig functions. I don't know what you want to call it. But anyway, that's the end of this problem set. I hope this was helpful, and good luck.